Nature is the primal, all-encompassing reality from which we emerge and to which we inevitably return, an entity so vast and multifaceted that its definition stretches from the subatomic tremor of quantum foam to the silent, cold expanse of intergalactic space. It is not merely the green world of forests and rivers, but the fundamental, indifferent machinery of the cosmos, the ceaseless engine of creation and decay governed by immutable laws. To contemplate nature is to confront the deepest structures of existence: time, energy, form, and transformation. It begins with the initial singularity, the first flare of light and heat that dictated the expansion of spacetime, giving rise to hydrogen and helium, the fundamental building blocks of all that follows. In the belly of gargantuan, ephemeral stars, gravity compresses these light elements until they fuse, forging the heavier elements: the carbon in our bones, the iron in our blood, the oxygen we breathe. We are, quite literally, stardust refined by stellar collapse and planetary accretion. This cosmic, deep-time nature, operating on scales of billions of years, sets the ultimate stage for our immediate environment. The formation of Earth itself, a fortunate alignment of mass, distance from a star, and the presence of liquid water, represents a singular triumph of physical law. Geology provides the narrative of the terrestrial shell, a continuous, violent history of plate tectonics, volcanism, and erosion, the slow, relentless sculptor of continents, mountains, and ocean basins. It is within this churning, molten, and often destructive physical matrix that the delicate miracle of biology took hold. Life, a complex and improbable expression of chemistry, emerged from primordial soup, an energetic system capable of self-replication and evolution. This biological nature is characterized by an astonishing, almost reckless biodiversity, a 4 billion-year-long experiment in adaptation and survival. Every organism, from the simplest archaea to the most complex cephalopods and mammals, is a temporary vessel of inherited information, fine-tuned by the relentless process of natural selection. The living world is an intricate tapestry of mutual dependencies, a global ecosystem operating far beyond the comprehension of any single human mind. Consider the complexity of a single forest, the symbiotic relationship between fungal mycelium and tree roots, trading minerals for sugars across an invisible, subterranean network that links hectares of flora. The flow of water, drawn from the earth and exhaled into the atmosphere, becoming cloud and rain in a ceaseless, global respiratory cycle. The carbon cycle, where photosynthesis captures atmospheric CO2, locking solar energy into organic compounds, only for respiration and decay to release it back into the aerial reservoir. The health of a remote rainforest in the Amazon is inextricably linked to the climate patterns of the Arctic, demonstrating that the biosphere is a single, interconnected, and profoundly sensitive organism. This is nature in its most immediate, perceptible form: the rustle of leaves, the scent of petrichor on dry earth, the complex architecture of a termite mound, the synchronized flight of a migrating flock. Yet, our experience of nature transcends mere scientific categorization. It is deeply rooted in our psychology and culture. Historically, nature was often viewed as a sublime, terrifying force, a wilderness to be conquered, a source of raw materials to be extracted, or a domain ruled by capricious deities. The human inclination toward anthropomorphism attempts to assign morality and intention to the neutral processes of the wild. We praise the beauty of a sunset and recoil from the cruelty of a predator's kill, forgetting that nature operates on a principle of utility and dynamic equilibrium, utterly devoid of human ethical judgment. The avalanche, the drought, the volcanic eruption, and the disease outbreak are not malevolent acts. They are simply manifestations of physical and biological necessity, resets in the continuous cycle. It is in the human perception of wildness that nature exerts its strongest spiritual and intellectual pull. In landscapes untouched by human engineering, we encounter a profound sense of awe: the vast, empty sky over a desert, the crushing power of an ocean storm, the silent, overwhelming scale of an ancient glacier. This awe is tied to our own insignificance, a momentary escape from the self-imposed constraints of civilization. It is the realization that the world preceded us, will continue without us, and operates by rules we can only partially decipher. This realization has driven philosophical inquiry and artistic creation for millennia, inspiring the Romantic movement, Transcendentalism, and the modern conservation movement. To the poet, nature is metaphor. To the physicist, it is equations. To the biologist, it is data. But to the human spirit, it remains an unfathomable mystery and the ultimate sanctuary. The challenge of the current era lies in reconciling human civilization with the inescapable demands of the natural world. Our mastery of technology, derived from an understanding of nature's laws, has led to a precarious imbalance. The scale of our resource consumption, the rapid alteration of global biogeochemical cycles, and the unprecedented rate of species extinction have placed immense stress on the systems that sustain us. Environmental degradation is not merely an ethical failure. It is a profound failure to understand that humanity is not separate from nature, but a highly integrated, dependent component of the biosphere. The air we pollute, the waters we foul, and the land we deplete are not external entities, but extensions of our own life support system. Stewardship, therefore, is not an act of charity toward the earth, but an act of pragmatic self-preservation. Ultimately, nature is defined by its resilience and its relentless flow toward entropy. It exists in the smallest detail of a snowflake's geometry and the grand narrative of celestial mechanics. It is the genetic code that binds all life together and the gravitational force that holds us to the planet. It is indifferent to our aspirations, yet provides the context for every one of our achievements. It is the silence beneath the noise of our cities, the quiet truth of our temporary existence, and the enduring reminder that our most sophisticated technologies and ideas are merely transient ripples on a vast, eternal sea of matter and energy. The profound, inescapable reality is that we are woven into this fabric, children of earth and starlight, subject to the grand, majestic flow of the whole, and finding our truest, most humble identity within its boundless, unyielding complexity. This boundless complexity reveals its elegance not only in the macrocosm of galaxies, but in the microcosm of the single cell. Within that tiny boundary, a universe of processes unfolds. The DNA helix, an architectural masterpiece of information storage, dictates the fate of the organism through a complex, error-checking transcription and translation system. The mitochondria burn fuel to power action, linking the cell's energy economy directly back to the stellar furnace that forged its elements. The cellular membrane acts as a sophisticated, semi-permeable gate, constantly engaging in diplomacy with its surroundings. We carry trillions of these miniature natural systems within us, and beyond our own cells, we host an entire secondary ecosystem, the human microbiome. These bacteria, fungi, and viruses, which outnumber our own cells, manage digestion, modulate immunity, and even influence mood and cognition, dissolving the absolute boundary between the self and the external biological world. This is nature operating as an endless sequence of nested systems, where emergent properties, like consciousness or the synchronized movement of a bird flock, arise unpredictably from the interaction of simpler, rule-bound components. From the simple, iterative rules of cellular division, the entire complex geometry of an elephant or a redwood tree emerges, following principles that hint at a deeper underlying code. One of the most striking revelations of studying nature is the ubiquity of its mathematical language. The forms that appear most spontaneous and organic are often governed by rigorous, beautiful numerical patterns. The spiral arrangement of seeds in a sunflower head, the coiling of a nautilus shell, the branching of river deltas, and the structure of a hurricane all frequently adhere to the Fibonacci sequence and the golden ratio, $/phi. These are not accidents but manifestations of energy-minimizing efficiency, nature's most optimal solutions for packing, growth, and flow, demonstrating that the aesthetic principles we find so pleasing are directly linked to fundamental physics. Likewise, the fractal geometry of coastlines, tree branches, and lightning strikes reveals a self-similarity across different scales. Zoom in or zoom out, and the basic pattern repeats, suggesting a